In this video, we will talk about chapter 9, which is the characteristics and the functions in instruction sets. Here we'll look at the machine instructions characteristics. The operation of the processor is determined by the instruction it executes, referred to as machine instructions or computer instructions. And the collection of different instructions that the processor can execute is referred as the processor's instruction set. Therefore, each instruction must contain the information required by the processor for the execution. And we will look about the element of a machine instruction. First of all, we have the operation code, which is opcode, and our source operand reference, our result operand reference, and the next instruction reference. This is the cycle state of those instructions and how they move along each other to complete the executions. And next we'll look at where the instructions where the element of the instructions can be used in. For example, the source and the result operands can be used in the main and virtual memory, and also I/O device, input and output device, the processor registers, and immediate address. Next, we'll look at the instruction types, which is the data processing, data storage, data movement, and control. Data processing is which the arithmetic instructions provide computational capabilities for processing numeric data, and the logic instructions operate on the bits of a word as bit rather than as number. So therefore, they provide the capabilities for processing any other type of data that the user may wish to employ. And on the other hand, the data storage is store the movement of data into or out of register or memory locations. While the data movement is the I/O instructions that are needed to transfer programs and data into memory and the result of computations back out of the user. While the control is the test instructions that are used to test the value of the data word or the status of a computations. Branch instructions are used to branch to a different set of instructions depending on the decision made. Next, we'll look at the instruction set design. It's a very complex because it can affect so many aspects of the computer systems, and it defines many of the functions performed by the processor and the programmer's means of controlling the processor. There are 5 fundamental design issues, which is the operation, repertoire, data types, instruction formats, registers, and addressings. Next, we'll look at the type of operands. We got 4 types of operands, which is address, numbers, characters, and logical data. First, we'll look at the numbers. All of the machine language include the numeric data types. Therefore, the numbers stored in the computers are limited to the magnitude of numbers representable on a machine, and in the case of floating point numbers, a limit to their precisions. There are 3 types of numeric data in the computer which are very common, which is a binary integer, binary floating point, and decimal. Well, there is one type which is a packed decimal, that each decimal digit is represented by 4-bit code with 2 digits stored per byte. And to form a numbers, 4-bit codes are strung together, usually in multiples of 8 bits. This is how the numbers operand works. And next we'll look at the characters operands. And the common form of the data of this operand is text or character strings. And the textual data in character form cannot be easily stored or transmitted by data processing and communication system. And most commonly used character code is the International Reference Alphabet (IRA). And the other code used to encode characters is the Extended Binary Code Decimal Interchange Code (EBCDIC). Next, we'll look at the logical data. It is an n-bit unit consisting of n 1-bit items of data, each item having the value 0 or 1. There are two advantages to bit-oriented view. The memory can be used most efficiently for storing an array of Boolean or binary data items in which each item can take on only the values 1, which is true, or 0, which is false. And it's easy to manipulate the bits of the data item. Next, we'll look at the single instructions multiple data types, SIMD data types. Is introduced to the x86 architecture as part of the extension of the instruction set to optimize the performance of multimedia applications. This extension includes the multimedia extension MMX and the streaming SIMD extension, which is SSE. And below here are their data types, which is 5 types of data types. And next we will move on to the ARM data types. And the ARM processor support of data types of 8 bytes, 16 harvest, and 32 bytes in length. All three data types can also be used for two complement signed integer, and for all three data types, an unsigned interpretation is support in which the value represents an unsigned non-negative integer. Therefore, when there is an online access, when this option is enabled, the procedure uses one or more memory access to generate the required transfer of adjacent bytes transparently to the programmer. And when the alignment checking occurs, when the appropriate control bit is set, a data abort signal indicates an alignment fault for attempting an online access. Next, we'll look at the data transfer. It is the most fundamental type of machine instruction when we execute a program or whatever, and it must specify the location of the source and the destination operands. Besides, the length of the data to be transferred must also be indicated, and the mode of addressing for each operand must be specified. Next, let's talk about the arithmetic operation. Most machines provide the basic arithmetic operations of add, subtract, multiply, and divide in their default system. These are provided for signed integer numbers. So they are often used for for floating point and packed decimal numbers. However, there are also some other possible operations, include a variety of single operand instruction, which is the absolute, which they take the absolute value of operand, negate, which they negate the operand, increment, that they add 1 to the operand, and decrement, they subtract 1 from the operand. Next, we'll look at the conversion. This is the instruction that change the format or operate on the format of data. One of example is converting from decimal to the binary. An example of a more complex editing instruction is the ES390 translate instruction. Next, we'll talk about the input and output. There are a variety of approaches taken using the input operand, which is the isolated program I/O, memory mapped program I/O, DMA, and the use of an I/O processor. There are many implementations provide only a few IO instructions with a specific action specified by parameters, codes, or command words. Next, we'll talk about system control. This is an instruction where the instructions that can be executed only while the processor is in a certain privileged state or is executing a program in a special privileged area of memory. And we'll talk about the transfer of control. There's a reason why transfer of control operation is required, because it's essential to be able to execute each instruction more than once, and virtually all programs involve some decision making, and it helps if there are mechanisms for breaking the task up into smaller pieces that can be worked on the same time. Most common transfer of control operations found in instruction sets are branch, skip, and procedure call. This diagram shows the example of the branch instructions. And this is the description about a skip instruction, where typically implies that one instruction be skipped. Thus, the implied address equals the address of the next instruction plus one instruction length. And because the skip instruction does not require a destination address field, it is free to do other things. And lastly, we'll look at the procedure call instruction. It's a self-contained computer program that is incorporated into a larger program. And there are two principal reasons for the use of a procedure call instructions, which is the economy, because this procedure allows the same piece of code to be used many times, and also the modularity. This instruction involves in two basic instructions, which is a call instruction that branches from the present locations to the procedure, and return instructions that returns from the procedure to the place from which it was called. And lastly, we'll look at the two operation types. We will describe briefly about that. One of them is the x89 operation types. These operation types provides a complex array of operation types, including a number of specialized instructions. The intent was to provide tools for the computer writer to produce optimized machine language translation of high-level language programs. While the other operation type is the ARM operation type, which consists of 7 instructions, which is the load and store, branch, data processing, multiply, barrel addition and subtraction, extend, and status register access. And that's all for the chapter 9. Thank you.